So have a look at questions 14 and 15 then. So the equation for the hydrogenation of ethyne, this must be ethyne here, and we've got hydrogen, addition of hydrogen is hydrogenation, makes ethane. Experimentally yields 65%, so we've made 65% of what we could have made. What's the mass in grams of ethane that can produce from 16.2 grams of hydrogen? So if I've got the molecular formulas of each of these, I can work out the MR. A carbon's got a mass of 14 and a hydrogen a mass of 1. So what's the mass in grams of ethane that can produce from 16.2 grams of hydrogen? I've been given a mass, I've got its MR. Why would it give me a mass and an MR? Surely I need to work out number of moles. So moles equals the mass divided by MR. H2, 2 ones, hydrogen having a mass of 1, its MR is 2, so I've got 8.1 moles of hydrogen. 8.1 moles of hydrogen. Why have they given me the equation? The equation is like a recipe really. It tells me the amounts. 1 mole reacting with 2 moles to make 1 mole. So 2 moles of hydrogen makes 1 mole of ethane. We want to work out the mass of ethane. I now know if I've got 2 moles of hydrogen and make 1 mole of ethane, I've got 8.1 moles of hydrogen, so I must make half the amount. I must make 4.05 moles of ethane. I know the number of moles of ethane that I can make in theory. So I should make 4.05 moles of ethane in theory. That's the theoretical yield, but I only make 65%. So 65% of that, 65 divided by 100 multiplied by 4.05, I actually only make 2.63 moles of ethane because I only make 65% of the yield. Now I've got the number of moles of ethane that I actually make. I know it's MR, 2 multiplied by 14 for the carbons, and 6 multiplied by 1 for the hydrogens is 30, and so moles equals mass divided by MR, so mass equals moles multiplied by MR, 2.63 multiplied by 30, 78.98 grams. 78.98 grams is B. The other way of doing it is that you could have actually worked out 4.05, converted that moles into grams, by multiplying 4.05 by 30 and then doing 65% of that would have come out with the same answer. What molecule does not have permanent dipole-dipole? Well, I've got Cl's in there and F's in there. So C to Cl has got a dipole bond in there. It's got a delta plus and a delta minus because Cl's and F's are electronegative. They're going to have delta minuses and leave a delta plus on the C. So you're going to end up with a polar bond in there, and between molecules, polar bonds then create dipole-dipoles. So all of them should have dipole-dipoles, except that if you have a completely symmetrical molecule, both along the x and the y-axis, if it's completely symmetrical, all the plus and minuses cancel each other out, and therefore it doesn't have a permanent dipole, and it doesn't have dipole-to-dipole intermolecular bonding. So which one is perfectly symmetrical? C with 4 F's around it is completely symmetrical, so the answer is C.